while new product development, we need to depend on design analysis and optimization. And prior to that, we need to depend on CAD modeling. For modeling, we are having different softwares. Among all these softwares, definitely SolidWorks is preferred. But at present, different premier institutions like IITs are following Autodesk Fusion 360 as a modeling software. So here in this series of modeling and assembly of engineering components, we will be using Autodesk Fusion 360 as a modeling software. Hi everyone, this is Professor Majumdar and you are watching ERUDIRE Plus, the professional CAD/CAM solution provider. Then let's get started. Hello viewers, today I'm going to model our 17th exercise and this one will be modeled using Autodesk Fusion 360. You can see three different views are available. This is top view, this is front, and this is the isometric one. It is evident that it is better to start with the top view, and as it is a symmetric one, we can sketch one half of the object and that can be mirrored, right? So we are planning to make this right hand side part first, and that will be mirrored with respect to the central axis or central line. Next to that, we can make this part, and finally we can make the extreme left hand side part. While modeling this part, we can have a sketch of this one, and that can be revolved with respect to the central axis, right? So without wasting time, let us start our modeling using Autodesk Fusion 360. First of all, we need to create one new design, and we can save this one by the name of exercise 17, and we can save it to a specific folder by the name of Fusion. Let us save this one. You can see exercise 17 is saved, and as I told before, we need to start from top view. So we are starting from here, sketch, and selecting the top view. As this one is a symmetric object, so we'll make one half of the object and that will be mirrored with respect to the central axis. So first of all, we can select that central axis, or you can select this construction line also. So starting with construction line, next to that we need to create some kind of circular arcs. So we can change the line type from construction to solid and create arc, and in this case we are starting with center point arc. Here it will be two concentric circles. The radius will be provided later on, right? And here also some distance, how you can make one circular arc. And again we can join some straight lines from here. So initially we are making the object, and later on we'll provide a smart dimension to provide the actual dimensions, right? And you can see that this one is having radius 15 mm and this one is 10 mm. And again another line is required here. Actually this one will be horizontal to this one, or you can say this line will be vertical to this one. That relation can be provided from here with constraints. This line is perpendicular to this one. Done. Now we can provide smart dimensions, and it can be started from here. This one will be having radius 15 mm, this one 10, and again this radius will be 4 mm. You see the drawing again. The distance from here to here will be 15.4 mm, and from here to here it will be 26 mm. So smart dimension from here to here it is 15.4 mm, and from here to here it will be 26 mm. Now in this case you can trim some unwanted entities. That can be done from here. Let us trim these unwanted entities from here, right? Now we can mirror this one with respect to the central axis or central line. So create mirror. Let us select all the lines. Done. Now we need to select the middle line. This is the middle line selected. Done. So this is our object. This is initial object, right? Now this one to be extruded to a specific depth, right? Let us see how much to be extruded. This one to be extruded to a depth of 10 millimeter, and it will be extruded symmetrically both sides, and the depth of extrusion will be 10 millimeter. Let us finish the sketch, and I need to extrude this one. So starting with extrusion, and from direction we can change from one side to symmetric one, and in measurement let us consider whole length to be extruded, and the extrusion depth is 10 millimeter. Done. You can see the object is made, right? Now next to that we need to start sketching again on this plane. Let us select that plane, start sketching. In this case we will be having one rectangle, and let us draw one rectangle from here. Initially we'll draw one arbitrary rectangle, and later on we can put some smart dimension to this one. Let us start with some construction lines here, because we have to make this one symmetric along this line, right? And we can put that symmetric conditions from here. This one, and this one is symmetric. Done. Now we need to provide smart dimension to this one, right? Let us see the drawing. So this will be actually a rectangle of length equal to 46.8 millimeter. Length will be double of this one, that is 46.8 millimeter length, and breadth will be 20 millimeter. So we can put smart dimension to this one. Length will be 46.4, and this one breadth will be 20 millimeter. Done. And again you can see this is symmetric with respect to this one also, right? So you can see the distance from the central point to this one, it will be above that 10 millimeter. Again you can select this one from here to this distance, this will be 23.2. Done. Drawing is complete. All the lines are black, so it is okay. We can finish the sketch, and that to be extruded to a specific depth, right? Let us finish the sketch and see how much to be extruded this one. The depth of extrusion in this case it will be 15 millimeter. So we can select extrude, and from direction we can select one direction only, and it will be extruded to a depth of 15 millimeter. Let us select that specific areas, and depth of extrusion is 15 millimeter. Done. Next to that we need to start creating a one sketch here, and that to be revolved with respect to the central axis. So let us start sketching from here, and you can select any specific plane. Better to select with the top view, and we can start sketching here itself, right? First of all we'll create one central line. Next to that we want to create some arbitrary lines. Let us start from here. Now we need to put some smart dimensions, that is distance from here to here will be 15 millimeter. Done. This one will be 8.1 millimeter. This one is 10.2 millimeter. And the distance from here to is 18 millimeter. From here to here is 18 millimeter, and from here to is 14 millimeter. And again the distance from here to here will be again 8.1 millimeter. You can see it is black, so we can finish the sketch, and that will be revolved with respect to the central axis, right? So let us revolve by 360 degree, and can join this one with the plane body. Okay, so you can see And also we need to provide some kind of fillet at this location. Let us see how much will be the fillet radius. It is 6 millimeter, I think. In this case, we need to provide some fillet of radius 6 millimeter. At both the ends, it will be provided, right? So you can select the specific edges. Selected. Now we can provide fillet radius 6 millimeter. Done. So our model is complete, right? To have a better reference, we can change it from normal one to a specific one. Let us provide this one to be metallic appearance. So hit A and you can put this one as metallic, and let us select this one is made up of copper, and we are considering this one to be polished copper. Done. Let us close this one. So this is our model, right? This was a very simple model, and we initiated the sketch from top view. We have drawn half of this model and provided a mirror of this one. Next to that, we have provided this rectangular sketch on this plane, and that was extruded to a depth of 15 millimeter. And finally, again on the top plane, we provided this sketch, and that was revolved with respect to the central axis, and that was revolved by 360 degree with respect to the central axis, right? So with this one, we'll conclude our 17th exercise. Thank you so much for watching this video. Thank you again. Bye. If you like this video, please subscribe and share. And if you have any kind of doubts, please write to me. Thank you so much for watching this video. Thank you again. Bye.